We're going to talk about end behaviors of polynomial functions today. Graphing polynomial function is a big topic in Algebra 2. If you're planning to take pre-calculus, you'd better have a firm knowledge about this topic. When you graph polynomial functions, one of the important information that you need to know is how they behave at both ends. I'm drawing some examples of polynomial functions. There are 4 different scenarios. I hate asking my students to solve problems by memorizing. So we're not going to memorize stuff. I mean, sometimes you need to remember stuff in math, but it won't last longer in your memory. Isn't that true? In this lesson, I'm going to introduce how to figure out the end behaviors of polynomial functions nice and quick. It's important to understand what the signs of numbers are going to be. Let's look at the first scenario. F of x is equal to 2x to the 5th power minus 7x squared plus 10,000. Wow, that's a big number. We have to think about when x is increasing and when x is decreasing. So when x is increasing to the positive infinity, increasing and increasing, increasing. And this x to the 5th power increasing very, very fast compared to the rest. This is a reason why we only care about leading coefficients, the sign of the leading coefficient, and then the degree. So when x is increasing, for example, you can start from 1, and you can do 2, or you can do 10, you can do 100. We know that when x is increasing, this 2x to the 5th power value is going to be increasing. And when x is approaching to negative infinity, meaning x is decreasing. So it's going to go to like -1, -10. You can plug in different numbers. We just need to find a pattern. So what's going to happen? This 2 to the x to the 5th power is going to be decreasing. Is the negative sign still survive because this is odd degree? So now we see that, oh, okay, so the entire f of x is going to be decreasing. Even though this x to the 2nd power value, or 10,000, is a pretty big number, but it cannot affect more than 2x to the 5th power does. So when the degree is odd and the leading coefficient, we have a positive leading coefficient, we know that the end behavior of this function, this kind of function, it's going to be down, down, up. And the next scenario, like we talked about before, we only care about this leading term because the rest of the terms, they're not going to affect that much. So we only care about the first leading term. All right, so when x is increasing, when x is approaching to positive infinity, let's see what's going to happen to this g of x. When x is increasing, when you plug in 1, 10, and 100, like I said, you can plug in different numbers. And when x is increasing, this x to the 5th power, we know that this is increasing, but there's a negative sign in front of it, so all the values are going to be getting smaller and smaller and smaller, even though the absolute values are getting bigger. Because of the minus sign, everything's going to be opposite, so the value is going to be, the outputs are going to be getting smaller. What about when x is approaching to negative? Cut. X is approaching to negative, meaning x is getting smaller than -1 and -10 and -100. Because we have an odd degree, all the negative signs are not are going to be surviving, so it's still there. right? And then there's another extra negative in front of 2. That means every time you have negative, 2 negatives makes positive, right? Opposite of opposite is going to be positive. So we see that the numbers are getting bigger. So in this case, the end behavior of this function, this kind of function, it's going to be up, down. Next scenario is we have even degrees. Even degrees. It could be 2 or 4 or 6. And we have a positive leading coefficient now. So let's see how the functions are going to be changing when x is increasing 1, 10, 100. So, even without plugging in, you see the x to the fourth powers are going to be getting bigger, right? So it's going to be going up, and there's no negative in front of it, so it's just going up. And when you plug in, when x is going smaller, getting smaller, so x is getting smaller so x is approaching to negative infinity, what's going to happen? Because of this even degree, even exponent, all the negatives are going to be, for example, negative 2 to the fourth power, all the negatives are gone. It's going to be positive. Negative 2 times negative 2, negative 2, and negative 2. You have even numbers of negative signs, so it's going to be plus positive 16, right? So we know that, all the negatives are going to be gone. So we see that, when x is approaching to really, really smaller number, it's still going up, right? So in this case, the end behavior is going to be up, up. Next scenario, when with even degree, and then we have negative leading coefficients. This one's easier than when the degree is odd. So x is approaching to positive infinity. X is getting bigger and bigger and bigger. 1, 10, 100. All right. So we know that x to the fifth power, x to the sixth power, this time is 6. X to the sixth power is going up, right? It's increasing. But because of this negative sign, what's going to happen? Because of this negative, everything's going to be opposite, right? Hundreds are going to be negative 100. Thousands are going to be negative 1,000. So it's getting smaller. Getting smaller. And what about x is decreasing, approaching to negative infinity, right? And what's going to happen? Negative 1, negative 10, and negative 100 keeps going down, right? But the negative sign with this even exponent doesn't do anything, right? This is going to be symmetric, right? Symmetric because of that even degree, even exponent. So we can say, all right, so all the negatives are just stuck in this x to the sixth power, so only this negative signs applied. So x to the sixth power, negative 1, negative 10, negative 100, the numbers are getting bigger, right? The numbers are getting bigger because of this 6 even exponent. So this value will be going up. But the thing is, there's a negative sign in front of it, so the value is still going down. So in this case, the end behavior is going to be down and down. I hope this helps understanding like how to like figure out the end behaviors of polynomial functions. Uh, there are two things to remember. You have to just focus on the leading term. Sometimes they don't put in the standard form, meaning the leading term is like hiding in the middle or hiding at the end. So you got to be careful. And you only take care about the signs, how they are changing. Okay, if it's increasing or decreasing, that's all.